And we know that the expectation of p hat is equal to the expectation of x1 till xn divided by n, right? So I'm going to let y is equal to the numerator. Okay, so this is to say the expectation of p hat is equal to the expectation of y divided by n, right? As we discussed before, so each xi's is a Bernoulli random variable. So the summation of a bunch of Bernoulli random variables should be a binomial random variable, right? Because we know that n is a constant. So this is equal to this. And y is a binomial random variable, its expectation should be equal to np, right? So you cancel those n's, it's going to be p. Here is pi, right? So here I'm going to write the variance of this one. So it's equal to 1 divided by this n squared variance of y, right? So it's n pi, 1 minus pi. So you cancel one of the n's. So it's going to be this, right? So which is this value and this value. Okay? When the sample size n is large, we can apply CLT. That is to say, p hat is approximately normal distribution with mean and variance, right? So I'm going to say, okay, so p hat approximately follows a normal distribution with, the mean and variance, right? If n is large. So which means if n is large, say larger than 30, right? So p hat can be applied to CLT. Or CLT can be applied to p hat. Okay? All right. So let's take a look at other applications of sampling distributions. Okay? So this application is called sampling distributions of the difference between two means. So if we assume that there are two groups, say two population groups, A and B, okay? And we assume that A and B are independent groups. Then we know that, A follows the unknown distribution with mu1 and sigma 1 square, and B also follows the unknown distribution with mu2 and sigma 2 square. Okay, now, in order to study the difference between mu1 and mu2, so we have to draw two samples. Say, let me change a color, okay? So this is my sample of A, and this is my sample of B. So from this sample, I can have x1 bar to denote, the mu1, okay? To estimate this mu1. And from this sample, we can have x2 bar. So using x2 bar, I can estimate this mu2. Okay, of course, if you want to draw a sample, you have to have your sample size. For this one, the sample size is n1, and for this one, the sample size is just n2. Okay, now, so what is the difference between mu1 and mu2? Right, intuitively, we will use the difference between, the sample means to estimate this mu1 minus mu2. Okay, then we have known that x1 bar and x2 bar are, random variables, right? So x1 bar minus x2 bar should also be a random variable. But what kind of distribution should this random variable follow, right? So we can prove this. So x1 bar follows a normal distribution with mu1 sigma 1 squared divided by n1, approximately. So if n1 is large, right, according to CLT. And so does x2. if n2 is large as well. Okay, then x1 bar minus x2 bar should follow a normal distribution with mu1 minus mu2, sigma 1, n1 plus sigma 2 squared, n2. Okay, so you prove this by yourself. Okay, I'm not going to ask you to prove that this one still follows a normal distribution. Okay, intuitively should follow a normal distribution. But what I would like you to do is to prove that the expectation of this one and the variance of this one should be equal to mu1 minus mu2 and this one, respectively. Okay, you do this by yourself. Okay, using the above conclusion, right? x1 bar minus x2 bar approximately follow a normal distribution with mu1 minus mu2, sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. Using this conclusion, we can do example 8.6. So we consider two populations with mu1 is equal to 6.5 and sigma 1 is equal to 0.9. And mu2 is equal to 6.0, sigma 2 is equal to 0.8. You draw a sample of size 36 from the first distribution and a sample of size 49 from the second distribution. So if the samples are independent, find the probability that the difference between two averages is greater than 1. Okay, so I will, So I will change a color from red to black. Okay, now we have two groups, right, as before. And we know that for the first group, the population mean is mu1 and population standard deviation is sigma 1. For this one, the corresponding parameters are mu2 and sigma 2. Okay, and then you draw a sample from this one and you draw a sample from this one. So the sample size of this one is 36 and the sample size of this one is 49. Now, we assume that the samples are independent and find the probability that the difference between two averages is greater than 1. Okay, so I'm going to say the sample mean for the first group is x1 bar and the sample mean for the second group is x2 bar. So the question is to say the probability that x1 bar minus x2 bar is larger than 1, right? It's larger than 1. Okay, so in order to solve this, we have to know the probability, the distribution of x1 bar minus x2 bar, right? So if you go back here, so you're going to find its distribution should be normal, right? Because we know that n1 is larger than 30, n2 is also larger than 30. So x1 bar minus x2 bar approximately follows a normal distribution with mu1 minus mu2, sigma 1 squared divided by n1 plus sigma 2 squared divided by n2, right? So we know that mu1 is equal to 6.5, mu2 is 6.0. And sigma 1 is equal to 0.9, take square, divided by 36. And this one is 0.8, take square, divided by 49, right? So we can have the exact value. That is to say, x1 bar minus x2 bar follows a normal distribution with 0.5 and the corresponding variance is equal to 0.19 square. Okay. Now, once you know this distribution, right, it's normal, so you can, so I will say this is equal to y. Okay, so in order to get y is larger than 1, you can use the z table again, right? So this is equal to y smaller or equal to 1. And I will transform this y to z using the formula, right? Using the formula. So this is my z. This is my z, right? And for this value is equal to 2.63. And you check the z table by yourself. Okay, so the final result is 0.0043. Okay, so the probability is also super low. Okay, it's very low. So that's how do we calculate, the probability of two sample means, right? So every time when you are asked to find the probability of something, right, the first idea that will come to your mind should be the distribution. Like what kind of distribution does your random variable follow, right? In this case, your random variable is this stuff, right? It follows this distribution by CLT. And then, because it's normal, then you can transform this y, to z, and use the z table to find your final conclusion. Okay, so I'm going to stop here. In the next class, we're going to finish this chapter. And if we have time, we're going to start chapter 9.